Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 8 Learning Target 3. Today we're talking about simplifying radicals with division involved. So the simplifying radical part, it says sometimes when you're simplifying radicals, you end up getting the same radical over itself. This radical cancels to 1. What we're talking about here is when you look at something like the square root of 3 divided by the square root of 3, that is the same as saying 3 over 3. 3 over 3 is just 1. Well, the square root of 3 over the square root of 3 is also just 1. So when we're simplifying radicals with division, we want to simplify the top, meaning break it down to prime factorization. And then same thing with the bottom. Okay, break it down to the prime factorization. If you have a radical over itself, cross it out. And then you have to reduce the remaining fraction. All right, so let's take a look at number 1. So I like to look at the square root of 75 over 300. You could opt to reduce the fraction that you see. If you see that there's common factors, if you recognize those common factors, you can go ahead and divide those out right away. But you may not see that. So what we're going to do is we're going to break apart the 75. 75 is the same thing, and it's almost like you have to make two little lists here. So 75 is that 25 times 3, and then it's 5 times 5 and 3. And then the 300, I'm going to do the same thing. So this is my list for 75 that's on the top. And then 300, that's 30 times 10. That's 3 times 10. That's 2 and 5. This is 3. This is 2 and 5. This is 2 and 5. So what happens here is you've got these two lists in your radical. So if I rewrite those, I'm going to change a color here. If I rewrite those as the square root of 3 times 5 times 5 on the top and the square root of 3 times 2 times 2 times 5 times 5 on the bottom, check out what happens. I can cross out the square root of 3 over the square root of 3. I can also cross out the square root of 5 over the square root of 5, and I can cross out the square root of 5 over the square root of 5 there. So what happens is this whole numerator ended up crossing out to be 1. This denominator ends up being the square root of 2 over 2. So you're left with 1 over the square root of 2 times 2. And that's a pair. That can come out from under the radical. So you get 1/2. You've eliminated the whole radical. You've simplified it, taken out all the common factors, and you're left with just 1/2. So let's take a look at number 2. In 32, I'm going to simplify that. 32 is the same thing as 8 times 4. 8 is 2 times 4. 4 is 2 and 2. 2 times 2, that's a 2, that's a 2, that's a 2. And then I have the square root of 50. 5 times 10, that's 2 times 5. And that's 5. Okay, so there's my two lists. If I put them back underneath the radical, the top list is 1, 2, 3, 4, 5 factors of 2. The bottom radical is a 2 and a 5 and a 5. So then I can cross off one of my 2's because I have the square root of 2 over 2. And then this pair of 2's is going to come out front. This pair of 2's also comes out front, and this pair of 5 comes out front on the bottom. So I'm left with 2 factors of 2 on the top and a factor of 5 on the bottom, and I've canceled out the whole radicals. Well, on the top, 2 times 2 is 4, so that's 4/5. Okay. Let's take a look at number 3. So in number 3, we have the square root of 80 on the top. 80 is the same thing as 8 times 10. That's 2 times 4. That's 2 times 5. And that's a 2 and a 2. So this 2 comes down, that 2 comes down, that 5 comes down. There's our list for the top. Then take a look at 45. So 45 is the same thing as 9 times 5. 9 is 3 and 3. and 5 is 5. So there's my list for the bottom. So if I put those two things back together, I have 1, 2, 3, 4 factors of 2 and a 5 on the top, and on the bottom, I have 2 factors of 3 and a 5. Well, guess what? The square root of 5 over the square root of 5 cancels out. Just like 5 over 5 would cancel out, the square root of 5 over itself will also cancel out. There's no other factors I can cancel from top and bottom, but this 2 can come out front of the radical, this 2 can come out front of the radical, and this 3 can come out front of the radical in the bottom. So I'm left with a factor of 2, a factor of 2, and a factor of 3 on the bottom. 2 times 2 on the top is 4, so I have 4/3 there for my simplified expression. Let's take a look at the square root of 45. So square root of 45 we just did. I'm going to copy that list right on over because we just looked at that one. Now let's look at the square root of 320. That's a big number there. So 320, that's going to take me a little while. I've got 32 times 10. That's 8 times 4. That's 2 times 5. That's 2 times 4. That's 2 and 2. That's 2. That's 5. That's 2 and 2. There's a 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 5. Okay, so that's my list for the top. That's my list for the bottom. I'm going to use this space over here because that list for the 320 got a little long, which I knew it would. So the bottom, I've got 1, 2, 3, 4, 5, 6 factors of 2. 2, 2, 2, 2, 2, and 2, and 5. So then I circle, bring a factor out, circle, bring a factor out, circle, bring a factor out. Square root of 5 over square root of 5 goes away. On the top, I have a 3, bring it out. This is going to equal a 3 on the top, and I brought out 3 factors of 2 on the bottom. So that's 3 over 8. 2 times 2 times 2 is 8. All right, let's take a look at number 5. Square root of 75 times 12. We already did 75, but I kind of forget, so I'm going to do it again. It's 5, 5, and 3, I think. So 25 and 3, yeah, so 5, 5, and 3. 12 is going to be, I'll call it 3 times 4. That 3 comes down, that's a 2 and a 2. So then I end up with, that's on the top, that's on the bottom, square root of 5 times 3 over square root of 2 times 2 times 3. And these square root of 3's cancel out. Square root of 3 over 3 cancels out, so I can get rid of them. This pair of 5 comes out front, this pair of 2's comes out front. I'm left with 5 halves. And then taking a look at number 6. Square root of 32, I did this one a couple times already. That was 5 factors of 2. I did that one. And then let's look at the 72. 72 is the same thing as 8 times 9. That's 2 and 4. That's 3 and 3. That's 2 and 2. 3, 3. There's my 2 lists. So on the top, I have 5 factors of 2. On the bottom, I have 3 factors of 2 and 2 factors of 3. Out, out. This comes out. Ooh, there's 2 factors of 3 that can come out. Here's a factor of 2 and 2 that cancels. So I could have canceled 3 more factors of 2. And in fact, why don't we do that? I'm going to back up here a second because I just started circling things out of habit and went probably way farther than I needed to. So take a look at this. What I should have done was this 2 over 2, this 2 over 2, and that 2 over 2. Look at how much more I canceled. I just went too fast. And then I bring that pair of 2's out, that pair of 3's out, and I'm left with 2/3. Now, I could have done it the way I did. I would have been left with 4 sixths. I would have had that, and then I just would have reduced that on the outside to get 2/3. Either way, you end up at 2/3. Both ways would have worked fine. But if you can cancel things before you simplify, then great. That's awesome. Okay, let's take a look at number 7. Square root of 36 over square root of 100. The thing about 36 is it's a perfect square. it's 6 times 6. And the square root of 100 is 10 times 10. So what's nice here is, yeah, you can go through the hassle of breaking everything down and canceling it out, or throw those two in your list. You've got 6 times 6 and 10 times 10. That's just a factor of 6's on the top and a factor of 10's on the bottom, and then reduce that. Both of those can be divided by 2, and you end up with 3/5. Okay, now you may not have recognized that these are perfect squares, and that's okay. If you didn't recognize that they were perfect squares, just do the whole prime factorization. You could keep going here. You could do 2 times 3. You could do 2 times 3 again. You could do the 2 times the 5. You could do the 2 times the 5, and go on and on and on from there. Same thing over here with the 9 over 64. So square root of 9 over 64. If I break down the top, 9 is the same thing as 3 times 3. If I break down the bottom, 64 is the same thing as 8 times 8. So yeah, I could still break down the 8, but those are perfect squares. So if you put them under the radical, you've got the square root of 3 times 3 on the top and the square root of 8 times 8 on the bottom, and you bring your perfect squares out. So that's the same thing as 3/8. Okay. Square root of 45 over 20. I've got 45 is the same thing as 9 times 5. That's 3, 3, and 5. 20 is the same thing as 5 times 4. 2 times 2 and 5. Then I've got 3 times 5, and also the square root of 2 times 5. So 5 over 5 goes away. 3 comes out, 2 comes out, 3 over 2. Square root of 36 is 6 times 6. Square root of 25, those are both perfect squares. 5 times 5. So that's what my radical looks like. I've got the square root of 6 times 6 on the top and the square root of 5 times 5 on the bottom. And those are pairs. That's 6 over 5. Boom. Okay, last two. I'm going to simplify life here in number 11 and say that 80 over 180 is the same thing as 8 out of 18. So right away, I'm just going to divide both by 10 because that reduces that number. Then all I'm dealing with is the 8 and the 18, and that makes life a lot simpler. 8 is the same thing as 2 times 4. 4 is 2 and 2. This 18 is the same thing as 9 times 2. That's 3 times 3 and 2. So there's your two lists for the top and the bottom. Now leaving that factor of 10 in there, all that would have done is given me a 2 and a 5 in both of these that I then would have been able to cross out. But I recognize that they both ended in 0, so I was just thinking, hey, they're both divisible by 10. I'm going to get rid of the zeros. Take that factor of 10 out before I even go any further. All right, so here's a 2 and a 2 that cancel. There's a pair of 2's that comes out. There's a pair of 3's that comes out. This is the same thing as 2/3. And last one that we're going to look at today, I've got the square root of 72. 8 times 9, 2 times 4, 3 times 3, 2 times 2, 2, 3, 3. And then 128. I'm going to bust out my calculator for this one because I don't remember what goes into 128. I know 2 will. 2 and 64. What if I did 128 divided by 4? 4 and 32. Let's do that. Okay, so 32 is the same thing as 8 times 4. This is a 2 and a 2. There's going to be a whole lot of 2's here. 2 and 4, that's 2 and 2. That 2 comes down, that 2 comes down. And one more because I got that 4 right there. So this 2 comes down, 2, 2, 2, 2. 1, 2, 3, 4, 5, 6, 7. So I've got 2 times 2 times 2 times 3 times 3 over 7 factors of 2. 1, 2, 3, 4, 5, 6, 7. All right, what goes away? 2 and 2, 2 and 2, 2 and 2, great. Here's a pair of 3s, comes out front. Here's 2 pairs of 2s, come out front. Yay. So I've got a 3 out front and a 2 times 2 on the bottom, which is 3/4. All right, there you have it. So when the whole point of this lesson is that when we are simplifying radicals, if we have the same radical on the top and the bottom, that radical can be reduced. That radical can be canceled out down to 1. Any number divided by itself is equal to 1, and that includes radicals. So thanks for tuning in, and I will catch you next time.